Hello everyone and welcome back to the AWS Solution Architect Associate series. Today we continue the domain 4, that is design cost optimized architectures, and our focus is on a topic that plays a major role in both the exam questions and the real world system design. It is cost optimized database solutions. Database often become the most expensive and most performance critical part of the cloud applications. In this video, we will learn how to choose the right database type, select efficient engines, apply the caching strategies, plan the capacity correctly, optimize the retention, and reduce operational cost using the AWS native tools. By the end, you will know how to design databases that are scalable, reliable, and cost efficient. Let's get started. Before optimizing any database, you need proper cost visibility. AWS allows you to tag the RDS instances, DynamoDB tables, snapshots, and the backups using cost allocation tags, helping you identify which environment or the team is generating the most database expense. Using AWS organizations and the consolidated billing, you can track database spend across environments and accounts. Tools like Cost Explorer, AWS budgets, and the cost usage report helps you monitor the storage usage and IO cost, provision capacity, backup cost, and replication overhead. Having visibility ensures we don't just optimize the database technically, but we can measure where cost actually goes and which optimizations matter the most. One of the biggest opportunities for cost optimization is selecting the right database type. If your workload doesn't require complex joins, transactions, or the relational consistency, using a fully relational database may be overkill. For flexible, high volume key value workloads, DynamoDB is often far cheaper and more scalable. For workloads needing relational features but automating scaling, Aurora Serverless v2 provides on-demand capacity without provisioning entire instance. For long-running transactional systems, RDS MySQL or the PostgreSQL may be more cost-effective than commercial engines. Choosing the right type prevents over-provisioning, reduces the operational cost, and ensures long-term scalability. Even within relational databases, engine selection impacts the most. MySQL is simpler and widely supported, but PostgreSQL offers more advanced features like indexing, partitioning, and performance features, often allowing smaller instance sizes. Aurora offers high throughput and faster recovery than RDS, which can reduce the cost by requiring fewer replicas or the smaller compute. But Aurora has a premium price per GB, so it's justified mainly for performance heavy workloads. Sometimes the most cost-effective solution is a homogeneous migration to PostgreSQL or a heterogeneous migration to DynamoDB when the workload supports it. Engine selection can drastically reduce your ongoing cost while improving the performance. One of the most cost-effective cost optimization strategies is reducing the direct database reads. By using ElastiCache, frequently accessed values are served from the memory instead of the expensive database queries. For DynamoDB, DAX provides the microsecond read latency and reduces the number of RCUs consumed, significantly lowering the cost. Caching drastically decreases the load on your primary database, allowing smaller instance sizes, fewer replicas, and more predictable performance, making your DB architecture far more cost efficient. Backups are essential, but they are also one of the hidden cost drivers. By default, RDS stores the automatic backups on high performance storage, which is costly for long term retention. A cost-optimized design uses the short automatic backup retention for operational recovery, period manual snapshots stored long-term, exporting the snapshots to S3 Glacier for the archival compliance. This ensures you meet the retention requirements without paying premium storage rates unnecessarily. Capacity planning ensures databases are not over-provisioned. For RDS, choosing the right or the correct instance size and IO tier avoids the paying for unused compute or the storage throughput. For DynamoDB, provisioning the right number of RCUs and WCUs or using the on-demand capacity mode reduces the over-provisioning and eliminates throttling issues. Monitoring actual usage through CloudWatch helps adjust the capacity over time to ensure you only pay for what you use. AWS provides multiple managed database services, and choosing the right one has a major cost impact. DynamoDB eliminates the provisioning and maintenance overhead and is extremely cost efficient for high-scale key-value workloads. Aurora Serverless version 2 allows you to scale database capacity up and down automatically, which is ideal for variable or the bursty workloads. Multi-AZ deployments improve the reliability but double compute cost, so they should be used based on the business requirements. Choosing serverless or the auto-scaling DBs prevent paying for idle resources and ensures long-term sustainability. Databases fail or slow down when connection counts spike. Using RDS proxy, it helps pool and share the existing connections instead of creating new ones. This allows you to run your database on smaller instance sizes while still supporting large and bursty workloads, especially the serverless applications like Lambda. Connection pooling reduces overhead, improves stability, and prevents you from scaling your database just to handle the connection spikes. Replication improves the performance, but it also increases the cost. Enable read replicas only when analytics or the read scaling requires them, not for every workload. Global replication features such as Aurora Global Database or the DynamoDB Global Database increases the storage and cross-region data transfer costs and should be used based on the strict latency requirements. Offloading analytics to replicas or S3 based systems like Athena is often more cost efficient than scaling the primary database. Managing replicas and retention wisely keeps your architecture lean and cost optimized. To design a cost optimized database architecture, you must combine several strategies. Choosing the right database type and engine, adding the caching to reduce the direct workloads, set efficient retention policies, scale capacity responsibly, and limit unnecessary replicas. These practices ensures your system stays high performing while minimizing the long-term operational cost aligned with AWS well architected guidelines. So to summarize, in this video we explored how to design the cost optimized database solutions on AWS. We covered choosing the right database type, engine selection, caching, retention, capacity optimization, connection pooling, and replication strategies. These concepts help architects reduce the cost significantly while maintaining performance and reliability. In the next video, we will continue domain 4, which is designing cost optimized network architectures, where we will explore the NAT gateway trade-offs and then VPC endpoints and routing patterns, different connectivity models like direct connect and VPN. If you are enjoying this series, don't forget to like, subscribe and share. I will see you in the next session. Thank you.